At the beginning, we shall briefly introduce the procedure of creating our image. Validate that the Maps Compact Framework 3.5 is selected. In order to support the function of uploading or downloading files to or from the target device, the Select FTP Server component is necessary. Select the 8042PS2 Keyboard Mouse USB HID Keyboard and Mouse component to support the keyboard and mouse with different interface. Select the AutoLaunch V100 x86 Compact 7 component to support our application to run automatically when starting. The high base registry supports component selected. The VGA 800, 600, 16 at 60 Hz is selected to support our LCD screen. Click on the Solution Explorer tab. Double-click the OSC Design rack to open this file in the code editor window and add the entries. This part is the entries for FTP Server. Launch Remote Display Application AutoLaunch Launch Qualcomm. The next part is for setting IP address. The last part is the entry for our own application. It enables the application to run automatically when starting. Next, we'll introduce our hardware. First are assigning the LCD screen on the box, which connects the e-boxes through a VGA interface. On the surface of the box, GPRS module is on the left side, while the Zigbee coordinator on the right. Both of them are connected to the e-boxes through report cables. In the box is our e-box, the driver circuit of the screen and other cables. The other parts include the source, a water well, and 3 capacities, each of which contains the kind of neutral solutions of nitrogen, phosphorus, or potassium elements. The controlling circuit consists of the Zigbee router, relay circuit, 4 valves, and wires connecting them. One of the valves is connected with the water well, and the other 3 are connected to the capacities. The pipe hose and the fuse is responsible for watering the plants. Firstly, the e-box is designed to run in automatic controlling mode. Power on the e-box and follow the guide to initiate the system according to the user's demand. Now what the user needs to do is only let the system control the irrigation intelligently. The sensors collect the temperature and humidity. The data will then be read and transmitted by the router, received by the coordinator, and pre-processed by the e-box. The e-box then sends them to Cloud Platform through the GPRS module. The Cloud Platform analyzes the data and sends relevant commands back. Then the e-box will transmit the demands to the router through the coordinator. After receiving the commands, the router will control the valves accordingly. Secondly, the system is controlled manually by cell phones or computers through web pages. The initial process is the same as automatic controlling mode. After the system is working normally, users log on our website and set the parameters of irrigation. Cloud Server extracts the parameters, generates the relevant commands, and transmits it to e-box. The e-box receives the command through the GPRS module and controls valves open and close. The system can adjust the proportion and the amount of water, nitrogen, phosphorus, potassium irrigated according to the practical situation, thus increasing the production of the food and reducing the water consumption. If most farmers in the world apply this system to their farm, famine is expected to be relieved. As for our report, we firstly introduce the background and present our solution. After that, the service experience and market analysis are given. Then it details the techniques we use to realize the system, including the hardware and software parts. After that, the algorithm using to determine the proportion and the amount and the data flow are given particularly. In the end, the testing method in which we develop our system is mentioned.